Let me begin recording. So now record. So I was pleading for 30 minutes because I was not exactly in a position to begin the class by 12. So before I begin, I would like to find out if I'm audible. Can you hear me?
Yes, sir.
Okay.
Yes.
Okay, let me share my screen. Today we're looking at deductive reasoning. Yeah, so I normally regard this as the second half of the semester. I was explaining the other time that the first half of the semester is like a sort of preparation for the second. And in that first half, we were going through some concepts in language and meaning. We were studying statements that are not logical. You remember we were doing metaphors, proverbs. We were looking at meaning defects. And we learned how to identify passages that are argumentative or not. So now it's time to study arguments. Now, different forms of reasoning. This is the most challenging topic in the semester, according to my experience with many students, and even with my personal experience of the course. So I want you to be very attentive. You need to listen carefully. You need to be very alert so that you understand everything. And then I'm going to take my time to explain it as meticulously as possible. Okay. Now, arguments are also called reasoning, or argument is for the purpose of this course, we regard arguments as processes of reasoning. And an argument is to argue is also to reason. And then we also call arguments syllogisms. So we're using the three terms interchangeably. Now, the two major categories of reasoning are deductive and inductive. We also have causal reasoning, but that's a form of inductive reasoning. Now for deductive reasoning, also called deductive argument or deductive syllogism. Now, this is reasoning in which the relationship between the premises and the conclusion is a logical relationship. And as a result of the logical nature of this relationship, it is a reasoning that permits only one conclusion. Now, this kind of reasoning is like a mathematical operation. When you say 2 plus 2, you have 4. You can't have 4 or another number. You can only have one conclusion. So this kind of reasoning is similar to a mathematical operation. So we'll find out why. Example, all men are mortal. Kofi is a man. Kofi is mortal. Now, when you look at this argument, if you say all men are mortal, and you say Kofi is a man, you can only conclude that Kofi is mortal. You can't reach another conclusion. You can't change and modify the conclusion. For instance, you can't say Kofi is immortal. You can't say a fire cabinet is mortal. Yeah, so that is the nature of deductive reasoning. Before we begin to study this kind of reasoning, we need to look at the two parts of a sentence in an argument. An argument is a passage, and a passage normally contains sentences. Now, the two parts of a sentence in an argument, they are just like the two parts of a sentence in English grammar. There's a part that is like the subject, and there's a part that is like the predicate. Now, the part of the sentence that is like the subject, we call it the reference class. And then the part that is analogous to what we know as the predicate in our grammar classes, we call it the attribute class. For example, all men are mortal. Now, the all men is the reference class. Are mortal is the attribute class. The reference class is that to which the sentence refers. If you know that part of the sentence to which the sentence is making a reference, that's the reference class. And then the attribute class is that part of the sentence that is attributing something to or saying something about the reference class. So one part of the sentence is that part that the sentence is referring to. The other part is the part that is saying something about the reference or the part of the sentence that the sentence is referring to. Now, let's look at the reference classes. When we come to the reference class, let me go back. We're saying that in the sentence, all men are mortal. All men is the reference class. Are mortal is the attribute class. Okay, so let's look at reference classes. Reference class can be finite or infinite. The infinite reference class refers to all members or no members of a class, either 100% or 0. Example, all men, no man, any man. So it is either all or none. That's the infinite reference class. It refers to an uncountable number of items in a class. All men is uncountable. You cannot also count any man. You cannot also say that any man is uncountable. So all men, no man, any man, these are uncountable references. That's why we call it the infinite reference class. On the other hand, the finite reference class refers to countable and particular members of a class between 0 and 100%. So anything between 0 and 100% is countable. So anything between 0 and 100% members of a class, you can count it. That's how you know, you were able to know that it is more than 0% or less than 100% because it is countable in the first place. For example, some men. Some men is countable. 80% of men, 5 men, 1 man, all the men, few men, almost all the men. Now look at all the men. All the men is not the same as all men. When you say all the men, you mean all the men in a particular context, all the men in this class, all the men in this university, all the men in this town. They are all countable. But when you say all men is uncountable. You can't count it. So all the men is countable, it is particular. Few men, they are countable. Almost all the men, they are countable to universal and particular statements. Now, statements containing infinite reference class are called universal statements. And those containing finite reference classes are called particular statements. Example of universal statements, all men are mortal. Example of particular statements, some men drink alcohol. So those sentences referring to countable items, we call them particular statements. Those statements referring to uncountable items, we call them universal statements. A little exercise. Which statements are universal and which are particular? This table is three-legged. Tables can be sat on. Someone? Go ahead. Someone. Someone. Go ahead.
Say,
1, 2, 3.
say, oh,
Yes, go ahead.
say, please, say the first sentence is a particular statement.
This, and then next person for the second.
Sir, labels can be sat on. It's universal.
Universal. And then Nuku, the third statement.
Sir, James and Mary passed the examination is particular.
Okay, good. Abu Bakr, the last statement. Abu Bakr.
All visitors should treat her as
Yes, what?
universal. Universal statements.
Okay, that's good. So please raise down your hand, bring down your hands. Let's move ahead since we don't have much time. So let's look at the question of the issue of validity. What is validity? An argument is valid if the premises make the conclusion necessary and the conclusion follows with certainty. Look at it again. An argument is valid if the premises make the conclusion necessary. If the premises make the conclusion necessary. Let's go back and see what it means. Look at this argument. All men are mortal. Kofi is a man. Can you not say that the premises make the conclusion necessary? You can see that it is the only conclusion you can reach. So these premises make the conclusion necessary. And then the conclusion follows with certainty. So there are two statements. The first one is that they make the conclusion necessary. And the second one is that the conclusion follows with certainty. So let's go and continue where we stopped. So we repeat that an argument is valid if the premises make the conclusion necessary and the conclusion follows with certainty. All valid arguments are deductive arguments. Inductive arguments are strictly not valid. We'll soon find out about that. So deductive argument is a purely mathematical argument. The relationship between the premises and the conclusion is logical. Okay, refer back to the example of deductive argument. We just did that. So let's compare it to an inductive argument. Now this is an inductive argument. 95% of men are honest. Peter is a man, therefore Peter is honest. The question you ask yourself, do the premises make the conclusion necessary?
No.
It doesn't. 95% of men are honest. Peter is a man. Peter, what if Peter is among the 5% that are not honest? So the premises don't make the conclusion necessary. And the conclusion does not follow with certainty. Peter could be among the 95, the honest 95. Peter could be among the dishonest 5%. So more than one conclusion is possible. Now you can see, I told you that in a deductive argument makes only one conclusion possible, but in this case, more than one conclusion is possible. Possible conclusion 1, Peter is honest. Possible conclusion 2, Peter is not honest. Okay, so let's move on. Now let's sort out another technicality. There is this hidden conditional if and then. Most of you are familiar with the if-then statement. If this, then that. If that, then this. If the school fees are too expensive, then I'll not go to school. If I'm rich, I can go to America. If the pandemic is still on, then I'll stay at home. If I'm hungry, then I'll go and eat. If this, then that. If that, then this. So those kinds of statements, the if-then statements, they are called conditional statements. Any statement containing if and then is a conditional statement. Okay. Now, what we're saying is that all arguments have hidden conditionals. All arguments have hidden conditionals. Let's see how it is. Let's see why. Now look at the categorical statement, all men are mortal. Remember the first premise, all men are mortal. You can translate all men are mortal to a conditional statement. So as a categorical statement, it reads all men are mortal. For conditional statement, you can say, if something is a man, then it is mortal. If something is a man, then it is mortal. That is the conditional version of the categorical statement, all men are mortal. Now, remember our original argument. All men are mortal, Kofi is a man, Kofi is mortal. Now change the categorical statement of premise 1 to a conditional statement. All men are mortal. If something is a man, then it is mortal. Then use it to replace the categorical statement of our original argument. So in this new argument, instead of all men are mortal, you have if something is a man, then it is mortal. Then Peter is a man, therefore Peter is mortal. So you can see that in any argument at all, you can translate what I normally call, you can translate what I normally call the major premise into a conditional. Okay. When you translate premise 1 into a conditional statement, then you see the argument more clearly. If something is a man, then it is mortal. Peter is a man, so Peter is mortal. So this is the conditional version of the deductive argument. So you have the categorical version where premise 1 is categorical. And then you have the conditional version where premise 1 is conditional. Both of them are still the same thing. But the conditional version will show you a lot of things that you will not see in the categorical version. Normally, when we are studying arguments in logic, sometimes we rewrite the arguments in their conditional form so that we can see how the argument is flowing more clearly. Now look at this. Categorical version, all men are mortal. Peter is a man, Peter is mortal. Now let's replace this argument. Let's put this argument in a symbolic form. All men are mortal, all A's are B's. So we use A to represent men, we use B to represent mortal. And then we find another terminology for Peter. So Peter will be X. So what you have is all A's are B's, X is an A, that is Peter is a man, X is a B, Peter is mortal. All A's are B's, X is an A, X is a B. So that's the symbolic version, putting the argument in symbols. Okay. Now look at the categorical version in symbolic form. If something is a man, then it is mortal. Peter is a man, therefore Peter is mortal. Now let's put it in symbolic form. If A, then B. X is an A, therefore X is B. If A, then B. X is an A, therefore X is a B. Don't mind my removing the X is. If you remove the X is for both the second premise and conclusion, it's still the same thing. If A, then B. A, therefore B. Or you can say if A, then B. We have A, therefore we have B. All right. Godfred, put off your mic. Now let's make a distinction between antecedents and consequents. Now remember the reference class and the attribute class. We said the reference class is like the subject, the attribute class is like the predicate. If we restate any categorical proposition as a conditional statement, that is, if we convert an argument into its conditional form, the reference class becomes the antecedent, and the attribute class becomes the consequent. If we restate any categorical proposition as a conditional statement, the reference class becomes the antecedent, the attribute class becomes the consequent. Example, all A are B, or if A, then B. The reference class in this case, A, is the antecedent. When you say all A are B, the first part is the antecedent. So if A, then B. Now all A are B is categorical. If A, then B is conditional. So you have categorical, all A are B, and you have conditional, if A, then B. We're saying that if you convert the categorical to the conditional, all A are B, into if A, then B, the reference class, in this case A, is the antecedent. So when you look at if A, then B, the reference class is what? Is A. That part of the sentence that begins with if, that's the antecedent. And then the part that begins with then is the consequent. So if A, then B, if A becomes antecedent, B is the consequent. So A is the antecedent, B is the consequent. So when you say all men are mortal, if something is a man, then it is mortal. So the first part of the statement, if something is a man, is the antecedent. Then it is mortal is the consequent. Okay. Now, so any other statement you see anywhere that refers to A, which is the antecedent of this sentence, will be either affirming or denying the antecedent. And any statement you see referring to B will be either affirming or denying the consequent. Now we've known that A is the antecedent, B is the consequent. So any statement anywhere referring to A is either affirming or denying the antecedent. And any statement referring to B, wherever you see it, it's either affirming or denying the consequent. For example, X is an A. Now we said all A are B. A is antecedent, B is consequent. Now we are seeing another statement, X is an A. What is that sentence doing? It is affirming the antecedent. Remember that the original premise is all A are B. All A are B. So if you see a statement, X is an A, that affirms the antecedent. X is not an A, that denies the antecedent. X is a B, that's a statement that affirms the consequent. X is not a B, that denies the consequent. Now let's look at an argument that affirms the antecedent. Now we said all A's are B's. X is an A, therefore X is a B. If you look at this argument, you see the first premise, which I see as a major premise. All A's are B's. If something is an A, then it is a B. And we said the part that starts with if is the antecedent. The part of the sentence that starts with then is the consequent. So obviously A is the antecedent and B is the consequent. Then you see X is an A. When you see X is an A, what is that sentence doing? It is affirming the antecedent. Yes, at the Mensa or at the Sylvester. Or rather, Kobe Lawrence. Did you raise your hand to ask a question? Okay. So look at this argument. All A's are B's. X is an A, X, therefore X is a B. Now all A's are B's. You can see that A is the antecedent, B is the consequent. X is an A, affirms, is a sentence that affirms the antecedent. Therefore, X is a B. Now, the conclusion is affirming the consequent because premise 2 has affirmed the antecedent. Now, when we get an argument in which the antecedent has been affirmed, we say that the whole argument affirms the antecedent, not just the sentence that affirmed it. So it's not just the second premise or the second sentence is affirming the antecedent. The argument is an argument that affirms the antecedent. It affirms the antecedent in order to say something about the conclusion. In this case, it affirms the antecedent in order to affirm the consequent. Let's look at an argument that denies the antecedent. All A's are B's. X is not an A. Now, X is not an A denies the antecedent. In this argument, or rather, this argument is an argument that denies the antecedent in order to deny the consequent. Now, look at premise 2. X is not an A. Because X has denied the antecedent, we say that the whole argument has denied the antecedent. Affirming the consequent. Now, this is an argument that affirms the consequent. All A's are B's. X is a B. So this is an argument that affirms the consequent. This particular argument affirms the consequent in order to affirm the antecedent. Denying the consequent. All A's are B's. X is not a B. Now, the statement X is not a B denies the consequent. So we can see that this is an argument that denies the consequent in order to deny the antecedent. Now, this is the rule for deductive reasoning. This is the rule for deductive reasoning. We only affirm the antecedent and deny the consequent in order to reach a valid conclusion. Any other operation will make the argument lose its validity. Now, we saw four kinds of arguments. We saw four kinds of arguments. An argument that affirms the antecedent, an argument that denies the antecedent. We also saw an argument that denies the consequent, an argument that affirms the consequent. And the rule for deductive reasoning is telling us that it is only arguments that affirm the antecedent and deny the consequent that are valid arguments. What it means is that arguments that deny the antecedent and also arguments that affirm the consequent are not valid arguments. They are formal fallacies. Now let's look at an example. All A's are B's. X is an A. That affirms the antecedent. So X is a B. Now, according to the rule, any argument that affirms the antecedent is a valid argument. So this is a valid argument. All A's are B's, X is an A, X is a B. Now look at the second one, the second argument. All A's are B's, X is not an A, denies the antecedent. X is not a B. Now this argument is not valid. An argument that denies the antecedent is not valid. Now let's change arguments to words. All Ghanaians are Africans. Peter is a Ghanaian. It affirms the antecedent. Therefore, Peter is an African. A valid argument. Now, this argument affirms the antecedent, so it is valid according to the rule. Now look at the next argument. All Ghanaians are Africans. Peter is not a Ghanaian. Denies the antecedent. Peter is not an African. This argument is not a valid argument. So we'll soon see why. Now, what is the technicality behind these results? The consequent is always a larger class of denotations or members compared to the antecedent. The consequent is always a larger class of denotations or members compared to the antecedent. Consequent contains the denotations of both the antecedent and possibly more. So first of all, consequent is a larger class of denotations compared to the antecedent. And secondly, consequent contains the denotations of the antecedent and also the denotations of possibly more items. Now, the consequent Africans contains more members than the antecedent Ghanaians. If you say so, all Ghanaians are Africans, and you say Peter is a Ghanaian, definitely Peter will be an African. That's because Africa contains a larger class of items compared to Ghanaians. So if you identify Peter as a Ghanaian and an African, if you say Ghanaians are Africans and you say Peter is a Ghanaian, definitely Peter must be an African. But when you say that Peter is not an African, in order to say that Peter is not a Ghanaian, then you'll be wrong. Because if you say Peter is not an African, the conclusion that Peter is not a Ghanaian does not follow with certainty. There are other African nationalities. There are other nationalities in Africa. So denying someone of being a member of being an African does not automatically mean that he's denied of being a Ghanaian. So when you deny something of membership in a smaller class, you have not denied it of membership in a larger class. But when you deny something of membership in a larger class containing all the members of a smaller class, you have automatically denied it of membership in a smaller class. Let's see how it works. Before we come to deductive arguments, let us look at some maps. Now, let's imagine that we drew boxes that show the sizes of the antecedent and the consequent. When you say all men are mortal, men is antecedent, mortal is consequent. We said consequent will be a larger class of items compared to men. Now, in the first place, all men are mortals. That's what the argument said. But not all mortals are men. Other animals could also be mortals. That is why you say that the consequent is usually a larger logical category than the antecedent. Let me use a closer example, Ghanaians and Africans. Now we said all Ghanaians are Africans. So, and we said the consequent, which is Africans, is a larger class of items. Now I just muted everyone, so I'm struggling to understand where the noise is coming from. Okay. So we said all Ghanaians are Africans. If all Ghanaians are Africans, then it suggests that Africans could be more than just Ghanaians. That is why we always explain that the consequent is normally a larger class of items. The consequent can accommodate more than the antecedent. When you say that the antecedent is part of the consequent, you're also saying that the consequent can accommodate much more. Now having looked at this example, let's go and look at the 4 kinds of deductive arguments so that we see why they differ from one another. Now, 4 kinds of deductive argument. First of all, we have modus ponens. Before we begin it, we have modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. Now, modus ponens is an argument that affirms the antecedent. All those arguments we were seeing that were affirming the antecedents, they are all modus ponens. For example, all A's are B's. X is an A, therefore X is a B. This is an argument that affirms the antecedent. Look at the conditional version. If something is an A, then it is a B. X is an A, therefore X is a B. So this is a modus ponens because it affirms the antecedent. All Ghanaians are Africans. Peter is a Ghanaian, therefore Peter is an African. Okay. Why is it so? I'll use this diagram to show why it is so. We said all Ghanaians are Africans. Peter is a Ghanaian, therefore Peter is an African. Now, if all Ghanaians are Africans, this is the box containing Ghanaians. If you say Peter is in this box, then automatically Peter is in the whole box, is in the bigger box. So when you say all Ghanaians are Africans, Peter is a Ghanaian, therefore Peter is an African. The argument is correct. It's a valid argument. Remember that Ghanaians is antecedent, Africans is consequent. That is why modus ponens is a valid argument. If you say all Ghanaians are Africans and you identify Peter as a Ghanaian, then automatically Peter is an African. That's a modus ponens. Now let's go back. Modus ponens, an argument that affirms the antecedent. All A's are B's. All Ghanaians are Africans. Peter is a Ghanaian, therefore Peter is an African. So any argument that affirms the antecedent is a valid argument. Now let's look at the fallacy of denying the antecedent. The fallacy of denying the antecedent. All A's are B's, X is not an A, therefore X is not a B. All Ghanaians are Africans, Peter is not a Ghanaian, therefore Peter is not an African. It's an argument that denies the antecedent. It's not a valid argument. It's not a valid argument. Peter could possibly be a Cameroonian. So when you say all Ghanaians are Africans, Peter is not a Ghanaian, therefore Peter is not an African. It's not valid. Let's look at the diagram again. Now look at the box Ghanaians, look at the box Africans. If you say all Ghanaians are Africans and Peter is not a Ghanaian, can you then say that Peter is not an African? You can't say that. If you say Peter is not a Ghanaian, then what you have said is that Peter doesn't belong to anything in this small box. But what about the whole of this space? Can Peter not be here? So if you say all Ghanaians are Africans, Peter is not a Ghanaian, therefore Peter is not an African. You can't be too sure. The premises do not make the conclusion necessary. And the conclusion doesn't follow with certainty. So it's not a valid argument. Remember, we said that for any argument to be valid, the premises make the conclusion necessary. And the conclusion must follow with certainty. If you say all Ghanaians are Africans, Peter is not a Ghanaian, therefore Peter is not an African. The conclusion doesn't follow with certainty. Peter can be a Cameroonian, or he can be a South African, or he can be a Kenyan.
Why won't he mention Nigeria?
So what it means is that any argument that denies the antecedent is not valid.
People are affirming. Someone is saying, hey, affirming you so.
Mandia Sare Kwabe, why is your microphone on? Okay. I'm sorry, I'm coming. Yes. So the fallacy of denying the antecedent. We said any argument that denies the antecedent is not a valid argument. Okay. Now let's look at modus tollens. All A are B. X is not a B, therefore X is not an A. Look at the conditional version or the conditional version. If A, then B. not B, therefore not A. Into words. All Ghanaians are Africans. Michael is not an African, therefore Michael is not a Ghanaian. This is an argument that denies the consequent. Is it a valid operation? Let's go back to the diagram.
It's not valid.
Now let's look at. No, look. Let me allow. Just let me allow you to look at the diagram before you conclude. Now look at Ghanaians. Look at the box Ghanaians. Look at the box Africans. All Ghanaians are Africans, right? If you say Michael is not a Ghanaian, oh, sorry. If you say Michael is not an African, in order to conclude that Michael is not a Ghanaian, is it valid or invalid?
It is valid.
It's valid. Okay.
Yeah.
So that's a valid argument. If you are able to conclude that Michael is not an African at all, then automatically he cannot be a Ghanaian. So you can deny that someone is a Ghanaian by denying that he's an African. So if you deny the consequent, then you can successfully deny the antecedent. So that's modus tollens. All A are B. X is not a B, therefore X is not an A. Look at that. All Ghanaians are Africans. Michael is not an African, therefore Michael is not a Ghanaian. This is modus tollens. So it is a valid argument. Let's look at another example. Someone's microphone is Henrietta. Okay. I think this example can bring it out more clearly. Now let's look at this. Let's look at a second example. A department in a university. All those studying in the Department of Physics are enrolled at the University of Ghana. Kelvin is not enrolled at the University of Ghana. So Kelvin is not studying the Department of Physics. Now, let's imagine that there is a debate about whether Kelvin is in the Department of Physics. Some people are saying Kelvin is in the Department of Physics. Some people are saying Kelvin is not in the Department of Physics. And then someone goes to the registry to find out whether Kelvin is enrolled at the University of Ghana. Then the registrar tells the person that Kelvin is not enrolled at the University of Ghana. So can you then say that Kelvin is in the Department of Physics?
No.
No. No, sir.
You can't say that. Now,
No, you cannot say that.
Yeah, you can't say that. So now, University of Ghana is the consequent. Look at the first premise. Look at the first premise. Sorry, let me mute everyone. Okay, so I've muted everyone. Now look at the first premise. What is the antecedent and what is the consequent? All those studying in the Department of Physics are enrolled at University of Ghana. So that means that those studying in the Department of Physics, that's the antecedent. And then enrolled at the University of Ghana is the consequent. If you look at that first premise, you can convert it to a conditional. If someone is studying in the Department of Physics, then that person is enrolled at the University of Ghana. That's the conditional version of that statement. If someone is studying in the Department of Physics, then such a person is enrolled at the University of Ghana. So studying in the Department of Physics is the antecedent. Being enrolled at the University of Ghana is the consequent. Now, the second premise is saying Kevin is not enrolled at the University of Ghana. So the second premise is denying the consequent. Once you have denied the consequent, that you can deny the antecedent successfully. That's a valid argument. So look again at look at this diagram. Look at Department of Physics, look at University of Ghana. All those studying in the Department of Physics are enrolled at University of Ghana. Kelvin is not at the University of Ghana. Therefore, Kelvin is not in the Department of Physics. That is a modus tollens, an argument that denies the consequent. And it is a valid argument. So look at modus tollens. All A are B. X is not a B. Therefore, X is not an A. Or you can say if A, then B. Not B. Therefore, not A. So modus tollens is a valid argument. What about the opposite of modus tollens? What about affirming the consequent? What about affirming the consequent? All A are B, X is a B, therefore X is an A. Now let's go back to this diagram. We say all those studying in the Department of Physics are enrolled at the University of Ghana. Kelvin is enrolled at the University of Ghana, therefore Kelvin is studying in the Department of Physics. Are you sure that argument follows with certainty?
No.
Yes.
No, sir.
No, sir.
Yeah, so if you say,
Not at all.
yes, if you say Kevin is studying at Kevin is enrolled at the University of Ghana, you cannot just conclude that he's studying in the Department of Physics because he could be in the Department of Chemistry. So any argument that affirms the consequent in order to reach a conclusion is not a valid argument. Remember that the University of Ghana is a consequent. An argument that affirms the consequent in order to reach a valid conclusion, cannot be a valid argument. Now let's look at this. The fallacy of affirming the consequent. All A are B, X is a B, therefore X is an A. Or if A, then B, B, therefore A. Now let's look at this. All Ghanaians are Africans. George is an African, therefore George is a Ghanaian. Is this a valid argument?
No, sir.
No, sir.
Yeah, so the premises do not make the conclusion necessary, and the conclusion does not follow with certainty. Yeah, so only conclusion that follows with certainties are deductive arguments. Only arguments where the conclusion follows with certainty are deductive arguments. Valid. So any argument where the conclusion cannot follow with certainty is not a valid argument. So that is why we say that it is a fallacy of affirming the consequent. If you affirm the consequent, it is a fallacy. If you deny the consequent to reach a conclusion, it is a valid argument. And then you saw what happened to the antecedent. If you affirm the antecedent, it is valid. But if you deny the antecedent, it is not valid. Let me show you the rules of deductive reasoning once again. Look at it here. So this is the rule for deductive reasoning. This is what we started with. Sorry, let me. So this is what we started with. We only affirm the antecedent and deny the consequent in order to reach a valid conclusion. Any other operation would make the argument lose its validity. So I believe when you go back to your textbooks and read this up, you'll understand it better. Okay, so let's go ahead. Okay, so we're saying that the explanation is that a consequent contains a logically larger category of denotations than the antecedent. So the fact that George is an African does not necessarily mean he's a Ghanaian. He may be a South African or a Cameroonian. If we affirm the consequent, we are not sure we can affirm the antecedent. That's the problem. In short, if we affirm the consequent, it will land us in the same kind of uncertainty we saw when we deny the antecedent. So let's look at another form of the fallacy of modus tollens. Now, sorry, the fallacy of affirming the consequent. All A are not B. X is not a B. Therefore, X is an A. Remember that two negatives form a positive. When you combine two negatives, what you have is a positive. So all A are B, X is not a B. You can as well remove the negatives in the two and have positive statements. All A are B, S is a B. So that is an argument that affirms the consequent. Once you have two negatives, then you have a positive. So all A are not B. X is not a B. That's an affirmation. It's not a denial, it's an affirmation. So that's another form of making an affirmation. So remember that, because you can be tested like this. Okay. Now look at this in words. All human beings are not goats. X is not a goat. Therefore, X is a human being. What kind of argument is this? All human beings are not goats. X is not a goat. It is an argument that affirms the consequent. You can see statement 1 are not goats. Statement 2 is not a goat. So it's an affirmation. Double negative is positive. So our double negative is affirmation. Okay. Now let's go ahead. Hypothetical syllogism. So now we have done two kinds of deductive arguments. We did modus ponens and we did modus tollens. Modus ponens is an argument that affirms the antecedent. Modus tollens is an argument that denies the consequent. Now the third kind of deductive argument, we call it hypothetical syllogism. An argument where the consequent of an initial or first premise becomes the antecedent of a second or subsequent premise. So you see the consequent of a premise, it becomes the antecedent of the next premise. Just like that. Let me give you an example. All A are B, all B are C. You can see that the consequent of premise 1 has become the antecedent of premise 2. And the consequent of premise 2 can become the antecedent of a third premise. So you can say all A are B, all B are C, all C are D, all D are E, all E are F, all F are G, and you continue down. That's why we say that the consequent of a particular premise becomes the antecedent of the next premise. And then the conclusion, what the conclusion does is to bring together the very first antecedent and the very last consequent. The conclusion brings together the very first antecedent and the very last consequent. In this case, it is A and C. Okay, let's look at the definition again. An argument where the consequent of an initial or first premise becomes the antecedent of a second or subsequent premise. And then the subsequent premises feature the consequence of their predecessors as their antecedents. Then the conclusion pairs the very first antecedent with the very last consequent. So now this particular example, you can stretch it from A to Z. You can say all A are B, all B are C, all C are D, all D are E, all E are F, and so on down to Z. Then the conclusion will be therefore all A are Z. So that's a hypothetical syllogism. That is how a hypothetical syllogism works. Okay, let's put it in words. All Ghanaians are Africans. All Africans are human beings. Therefore, all Ghanaians are human beings. So all A are B, all B are C, therefore all A are C. You can even put it in conditional form. Look at the second example. If you're a Ghanaian, then you're an African. If you're an African, then you're a human being. Therefore, if you're a Ghanaian, then you're a human being. So you can see that all the three statements are conditionals. Now the explanation. We notice that the consequent of the first premise, which is B, becomes the antecedent of the second premise. And the antecedent of the second premise, which is the consequent of the first premise, leads us to a new party, which is C. So that's how it works. Now let's look at two fallacies of hypothetical syllogism. Hypothetical syllogism has two fallacies. Let's look at the first one. The first fallacy, all A are B, all B are C. Therefore, all C are A. So the problem is in the conclusion. Instead of saying, therefore, all A are C, you say, therefore, all C are A. Now, let's put it in words. All Ghanaians are Africans, all Africans are human beings, therefore, all human beings are Ghanaians. So you can see it's a hypothetical fallacy or a fallacy of hypothetical syllogism. Look at the conditional version. If you're a Ghanaian, then you're an African. If you're an African, then you're a human being. Therefore, if you're a human being, then you're a Ghanaian. You can see it doesn't work. Okay. Then the second fallacy of hypothetical syllogism. Yeah, so this one is different. All A are C, all B are C. So you can see this one is not all A are B. It just went straight to all A are C, all B are C. Therefore, all A are B. Let's put it in words. All Ghanaians are Africans. All Kenyans are Africans. Therefore, all Ghanaians are Kenyans. So it doesn't work. It doesn't work at all. Now look at the conditional version. Let's begin with the symbolic conditional version. If A, then C. If B, then C. Therefore, if A, then B. Look at it. If you're a Ghanaian, then you're an African. If you're a Kenyan, then you're an African. Therefore, if you're a Ghanaian, then you're a Kenyan. So it doesn't work. So that's the second hypothetical fallacy. Sometimes it can be true by accident. But the fact that it is true by accident doesn't mean that it is true by design. Now let's look at this. Ghanaians are human beings. Africans are human beings. Therefore, Ghanaians are Africans. All Ghanaians are human beings. All Africans are human beings. Therefore, all Ghanaians are Africans. So this is true. Or rather, the conclusion is true, but it is true by accident. Now, if you look at this argument, the conclusion is not true because of the structure of the argument. It is true because of what you know outside the argument or before you saw the argument. Already you know that all Ghanaians are Africans, but you didn't discover that in this argument. So this argument is true by accident, but the argument itself is incorrect. The conclusion did not come from the premises. So you should be able to distinguish when an argument is, the conclusion of an argument is true by accident, and when the conclusion of an argument is true because of the structure of the argument. Okay. Let's look at it. The last kind of deductive argument. Just a few seconds. Now, this is the last kind of deductive argument. A syllogism where the main premise is disjunctive. So a disjunctive syllogism is a syllogism where the main premise is a disjunct, either or. You know, when you see an either or statement, when we affirm something of any of the disjunctive items, then we have automatically denied it the other disjunctive part. Now look at this. Either A is true or B is true. A is true, so B is false. Either A is true or B is true. A is true, so B is false. You know. Or either A is true or B is true. B is true, so A is false. Now look at it. If one of them is true, then the other must be false. Either I became a reverend father or I got married. I got married, so I didn't become a reverend father. Or either I became a reverend father or I got married. I became a reverend father, so I did not get married. So we call it a disjunctive syllogism. So a little exercise. Determine what kind of argument this is. Now look at this argument. Anytime he goes to town, he passes by my mother's house. Today he passed by my mother's house, so he went to town. What kind of argument is this?
So it's valid.
Disjunction.
Yeah, but what kind of argument? Now, we saw modus ponens, modus tollens, hypothetical syllogism, and we saw disjunctive syllogism. We also saw the bad form of modus ponens and the bad form of modus tollens. To know what kind of argument this is, you first of all have to find out what is the antecedent and what is the consequent. So who can tell me the antecedent? Yeah, someone raised his hand. Nuku.
The antecedent.
Yeah, so the antecedent is
Anytime he goes to town.
anytime he goes to town. Yes, that's fine. So can you educate the others on how you discover the antecedent? How did you find out the antecedent?
Sir, I don't know how to explain it.
Now there are two premises. You look at those two premises very well. One of them one of them is convertible into antecedent and consequent, but the other one is not. If you look at today he passed by mother's house, if you look at premise 2, today he passed by my mother's house, you can't convert it into a conditional statement where you can get antecedent and consequent. It is premise 1 that you can convert into a conditional statement. And then the part of the sentence that begins with if is the antecedent, the part that begins with then is the consequent. So that's the first thing. Yeah, let me see everyone. Okay, so I've muted everyone. So when you look at the various premises, you need to find the one that you can convert into a conditional statement. Any statement you can convert into a conditional statement, that is where you locate, that is where you find the antecedent and the consequent. Anytime he goes to town, he passes by my mother's house. So you can say, if at all he's going to town, if he is going to town, then he will pass by my mother's house. If he goes to town, then he will pass by my mother's house. That's a conditional version of the statement. So the part of the sentence that begins with if is the antecedent, and that's going to town. And then the other part that begins with then is the consequent. That's passing by my mother's house. So that is how he discovered that the antecedent is anytime he goes to town. Now, having achieved that, the next thing is to ask yourself, the second premise, what is it doing? Is it affirming or denying the antecedent? Or is it affirming or denying the consequent? Is it an argument that affirms the antecedent, denies the antecedent, or affirms the consequent or denies the consequent? Yes, Nuku.
Sir, it affirms the consequent.
It affirms the consequent. Now, any argument that affirms the consequent, is it a valid argument? Yes. Appear.
No, sir.
Yes.
No, sir.
Yes.
It is not a valid argument.
Yes, it is not valid. If you affirm the consequent, it's not a valid argument. If you say that Kevin is enrolled at the University of Ghana, therefore Kevin is in the Department of Physics, it's not valid. Because enrolling at the University of Ghana doesn't automatically land you in the Department of Physics. You can enroll at the University of Ghana from any other department. So if you say that I am an African, so I am a Ghanaian, it's not a valid argument. You can't determine my Ghanaian identity by simply saying I'm an African. So this is a fallacy of affirming the consequent. It is the fallacy of Modus Ponens. But if you were looking at it, you would not suspect. You can only know by doing your proper analysis. Because nothing shows that passing by my mother's house is larger than going to town. You know, you can't find those kind of things by just looking at the words. You have to perform your operation. You have to do the procedure, find out what is the antecedent and find out what is the consequent. And the consequent is always larger than the antecedent. There's no exception. Okay, let's go ahead. Now, answer correctly. We deduce correctly when we deny the antecedent. True or false?
False.
False. That's correct. Number 2, we deduce correctly when we affirm the antecedent. True or false?
True. True.
Okay, that's correct. Now, number 3, we deduce correctly when we deny the consequent. True or false?
True.
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 Okay, that's great. Now, number 4, we deduce correctly when we affirm the consequent.
False.
False.
True.
The false.
It's false.
False. False.
All right, so now let's progress to the next subtopic, validity versus soundness. This is a very interesting part. Now, the 4 types of deductive syllogism are 4 ways of making deductively valid arguments. So a modus ponens is valid, that is affirming the antecedent. A modus tollens is valid, that is denying the consequent. A hypothetical syllogism is valid. A disjunctive syllogism is valid. So there are 4 kinds of valid arguments, only 4 kinds. So a valid argument is an argument whose premises are logically consistent with its conclusion. The premises of a valid argument necessarily imply its conclusion in the manner that it is impossible to deny the inference without running into self-contradiction. So you cannot deny a valid argument. You can't deny a modus ponens, you can't deny a modus tollens, you can't deny a hypothetical syllogism, you can't deny a disjunctive, you can't deny any of those arguments unless you want to make yourself contradictory. And then if you try to go against the valid arguments, then that's a formal fallacy. So the fallacy of modus ponens, that is denying the antecedent, is a formal fallacy. And then the fallacy of modus tollens, that's the fallacy of affirming the consequent, is also a formal fallacy. The 2 hypothetical fallacies, or the 2 kinds of hypothetical fallacies we saw, are also formal fallacies. Okay, so let's move on. Valid but not sound. An argument can be valid but not sound. An argument can be valid but not sound. Example, all human beings are immortal. Peter is a human being, therefore Peter is immortal. This argument is valid because it's a correct modus ponens. But it is not sound because one of the premises is not true. Now we changed mortal to immortal. The argument is still valid because it affirms the antecedents. So it's a valid modus ponens. But is the argument true? It's not true because the conclusion is not true. Peter is immortal is not true. Why is it not true? Because premise one contains false information. It's not true that all human beings are immortal. So that falsity or that falsehood entered the conclusion. So an argument can be valid but not true. If an argument is valid but it is not true, then the argument is not sound. For an argument to be sound, it has to be valid and it also has to be true. Another example, all men are mammals. All mammals must get killed. Therefore, all men must get killed. So you can see, first of all, what is the nature of this argument? Who Who can tell me the nature of the argument? All men are mammals. All mammals must get killed.
Hypothetical.
Yes, it's hypothetical. The consequent of premise 1 has become the antecedent of premise 2. And then the conclusion brought together the first antecedent and the last consequent. So it's a hypothetical syllogism. If it's a hypothetical syllogism, then it's valid. But is the argument true? It's not true. It's not true that all men must get killed. And that problem started with, the problem started in premise 2. All mammals must get killed. That is false. And then that falsehood entered the conclusion. Okay. So it is another argument that is valid but not sound. Now we have invalid argument with true conclusion. So this one is a reverse. An argument can have a true conclusion, but it doesn't mean the argument is correct. The argument can be invalid, although the conclusion is true. Example, democracy is better than other forms of government, of political organization, because citizens in a democracy are holier than citizens in another form of political organization. Which one is the conclusion and which one is the premise? The conclusion comes before the premise. The conclusion is democracy is better than other forms of political organization. That's the conclusion. Then the second part, because citizens in a democracy are holier than this and that, that's the premise. So you have the conclusion followed by the premise in one single sentence. If you look at the conclusion is true. Democracy is better than other forms of political organization. That is true. But what about the premise? Is the premise correct? Because citizens in a democracy are holier than citizens in another form. That's not correct. So this is an argument with a true conclusion, but an invalid argument. So look at the end of the slide. True conclusion alone does not make an invalid argument correct. Then we have valid and sound. To be sound, all the premises in a valid argument must be true. All men are mortal. Peter is a man. Peter is mortal. Okay. Sorry. So this argument is valid. It affirms the antecedent. And it is sound because it is true. All the information in the argument are correct. So it is not only valid, but it is true. An argument that is valid and true is sound. So we can have three forms. We can have valid and sound. We can have valid and unsound. We can have invalid and unsound. Valid and sound. All snakes are reptiles. That is true. Cobra is a snake. That is true. Therefore, cobra is a reptile. That is true. So everything here is true. And it is also, cobra is a snake. That's affirming the antecedent. So it is an argument that affirms the antecedent. It is a valid modus ponens, and it is true. So it's a sound argument. So valid because it follows the correct rule for deductive reasoning, affirming the antecedent, and it is true because all the premises are true. Now let's see this one, valid but unsound. All snakes are reptiles, that is true. Mosquitoes are snakes, that is false. Therefore, mosquitoes are reptiles, that is false. So the problem of falsehood began with premise 2 and ended in the conclusion. Now, what kind of argument is this? All snakes are reptiles, mosquitoes are snakes. It affirms the antecedent. So it's a modus ponens. And in fact, it's a valid modus ponens. So it's a valid argument. But it does not contain true information. So it is valid but unsound. Okay. So both valid and unsound. All snakes are reptiles. That's true. Mosquitoes are reptiles. That's not correct. Therefore, mosquitoes are snakes. So the argument is not true. What about the structure of the argument? What kind of argument is this? All snakes are reptiles. Mosquitoes are reptiles. So affirms the consequent. An argument that affirms the consequent, that's a fallacy. That's a fallacy of affirming the consequent. So it is invalid and it is also not true. Invalid because the argument affirms the consequent, unsound because one of the premises is not true. Is an invalid but sound argument possible? No. An invalid argument is unsound. It cannot be sound. Even if the premises and the conclusion are all true. So all Ghanaians are Africans is true. Kofi is an African is true. Therefore, Kofi is a Ghanaian. Now, so Kofi is an African. It affirms the consequent. So it's a fallacy of modus tollens. So the argument is invalid, but the conclusion that Kofi is a Ghanaian can be correct. It can be true. But it is not true because of the structure of the argument. You can only know whether Kofi is a Ghanaian from information coming outside this argument. You can't know that from the two premises. So the technicality is that validity is needed for soundness. Validity is needed for soundness, but soundness is not needed for validity. An argument can be valid and it is not sound. Some arguments are valid but not true. Now, soundness needs both validity and truth. Soundness needs both validity and truth. Now, a little exercise. Identify the missing premise in each of the following deductive arguments. All military men play football. Bob plays football. There's supposed to be a third statement. What will it be?
Bob is a military man.
Bob is a military man. That's correct. All Americans are human beings. All Americans are mimers. What's the third statement?
All human beings are mammals.
Okay, all human beings are mammals. Okay, that's correct. Yeah. Answer correctly. Which fallacy is committed by the following? All A's are C's, all B's are C's, therefore all A's are B's.
All these are C's.
Yeah, what do you call this kind of fallacy?
Sir, please come again.
What is the name for this kind of fallacy?
The rhetorical fallacy of rhetorical syllogism.
Do you mean hypothetical syllogism?
Yeah.
Yes, please.
Yeah, so that's the fallacy of hypothetical syllogism. Describe the following arguments. All Europeans are not my friends. Ben is not a European, therefore Ben is not my friend. First of all, you need to do a little mathematics here. All Europeans are not my friends. Ben is not a European. You notice that the first and second statements are negatives. So you can remove the word not in both sentences and just read them without the not, since two nots is a positive. If you remove the not in statements 1 and 2, what do you have? What type of argument is it? Yeah, Paddison. Francisca.
Modus Ponens.
A modus
Ponens.
A modus ponens. That's correct. Okay. So all Europeans are my friends. Ben is a European. So that's an argument that affirms the antecedent. So you can see the second one is just a different way of stating the first. No European is my friend. Ben is not a European. So you remove the two negatives. Any European is my friend. Ben is a European. So that's an argument that affirms the antecedent. Just remember that anytime you see two negatives, then it is a positive. So we'll do inductive reasoning next week. Any questions?
Sir.
Go ahead.
Sir, please, did you tell the class rep to make all of us write our IDs and names in the chat section?
Let me see. Let me see the chat. Then that's an instruction from the course rep. It's fine. Just go ahead and write your names. The course rep will get back to me.
Oh, okay, sir. Thank you.
All right, you're welcome. And then, so course rep, please, where are you? Is course rep around? Okay, course rep, call me after the class. So now I think I've taken my time to download this topic as much as I would want you to understand. So please go and watch this video. I'm uploading this video immediately. And I'm hoping you've bought your textbooks. You need to go and read this argument in your textbooks, do all the exercises so that you'll be able to pass the exams. At least you can see how challenging the course has become. This is the first difficult topic since we started. The next ones are also going to be a little bit challenging, but I think this one is the most challenging. So please buy your textbooks, read them, do all the exercises, watch this video several times. Felix.
Say, please, when are we having an eye?
Hey. Yeah, expect it on Monday. All right, so I'm going to leave you guys. Felix, do you have a last word? Okay.
No.
All right, so please have a very good day. We shall be encountering by Wednesday next week for inductive reasoning. Bye-bye.
No pray. The day is not where we started.